Good morning, class. The next module that we're going to look at is Module 8, Developments and Intersections. I want to get this out as quickly as I can because we have stopped the 2-week assignments, and now we're going to, the last two assignments, the last two modules are going to be 1 week in length, okay? So Module 8, the two drawings that you're going to work on for Module 8, those are both going to be due a week from yesterday, this past Sunday. So I want to get this out as quickly as I can so that you're able to work on these. The following module, as you see on the screen in front of you, Module 9, Fasteners, is also a 1-week assignment, okay? So both of these, they have a really reduced number of drawings, obviously, because we're only going to be working on them for 1 week. And I'll be walking you through step by step how to create these drawings. Okay. The next module, or whatever you want to call it, after Fasteners is the final project. Okay. I may release the final project before Module 8 and Module 9 are due, just to give you a little bit of extra time. And when I do, there'll be a video that I'll make that will basically, talk you through what the final project is and what all the details are there. But first things first, let's look at Module 8. Okay, so Module 8 is Developments and Intersections, and this is Chapter 23 in your textbook. Basically, developments and intersections are, or developments, I should say, are what the term that we use to describe taking a three-dimensional object and unfolding it. Okay, so think of a box, right? We've all gotten Amazon shipments during the pandemic, so we probably have a lot of boxes that we either have in our basement or that we've thrown away. But basically, what we're talking about is a drawing of a box that then you figure out how to unfold that box and then make a drawing of that. So a development is basically a representation, a drawing of a three-dimensional object that has been unfolded like a box, okay? And in fact, the drawing that we're going to work on first here, the hexagon box, you'll see that it is a hexagon-shaped three-dimensional object that I'm going to show you how to unfold and then draw as a development. That is an unfolded representation of that box. In the assignment for the hexagon, if you print it out, if you finish it and then print it out and cut out the shape of the hexagon, you should be able to fold that back up and create a hexagon shaped box. Okay. An intersection refers to how we handle graphically two of these three-dimensional objects intersecting each other, and what the corresponding shape would be to describe that intersection, okay? And that we're going to handle in the reducing T drawing, CAD exercise 8.2, okay? But first things first, let's look at the hexagon box. Okay, the hexagon box, what you're going to be drawing is the hexagon box, which is figure 2359 in your textbook on page 855. Okay. It's a truncated hexagon. That means it's a hexagon that's had the top of it cut off at an angle. All right. And I'm giving you the dimensions for the hexagon box here. The width is 1.75. That's the width across the flats. I'll explain what that means. And then the height at the highest point is 2.88 inches. Okay, so this is going to be drawn with the mechanical inch template. Everything else stays the same with our drawings. So, we're not really doing anything more with our drawings. You are not going to apply dimensions to this. Okay, so we don't have to do that added step. All we're going to be doing is drawing the 3D shape. Well, I should say we're going to be creating the orthographic views of the three-dimensional object, and then we're going to be unfolding it, okay? So I'm going to probably, because this may be a long video, because I'm going to go through the entire construction in AutoCAD. This may be a part 1 and a part 2 drawings. Who knows, a part 3 drawing, depending on how quickly I go here. All right, so let's get started. So I'm going to start a drawing, and we'll start a new drawing. Here we go, and I want to use the mechanical inch template. Okay, so now to get started, the first thing we have to do is we have to actually draw the three-dimensional, the orthographic views of the three-dimensional object. And in your textbook, they basically give you those 2 views. So this isn't really anything that's going to be difficult for you. The height and width are specified in the assignment, 1.75 for the width and 2.88 for the height. So I'll just go ahead and draw these. Now, there is going to be, I think, a new command that we're going to look at, and that's the Polygon Command. So let's do that first. So I'll draw the top view first. So the Polygon Command can be found under the rectangle command here. If we click on the little down arrow, you can see Polygon, and we click on that. And it asks us first to enter the number of sides. This is a hexagon. Hex means 6 sides. So I'm going to type in 6 here and hit enter. And then it asks us for a center point, and it doesn't really matter because we're starting the drawing, so I'll pick right here. And now it asks us inscribed in a circle or circumscribed about a circle, okay? So basically what this is talking about is how was the dimension of the hexagon provided to us? In other words, is it specified as width across the flats or width across the corners? And in this case, when you look at the figure in the book, the W, the width, the 1.75 inches, is specified as a width across the flats. Okay, width across the flats. The flats meaning the flats of the hexagon. When you are given the width across the flats, you must use circumscribed about a circle. Okay, so click circumscribed, and then we're going to specify. Now, here's where AutoCAD kind of drops the ball. And I've grumbled about this for, I don't know, probably 30 years. But AutoCAD then prompts us for the half distance across the flats. The half distance. Notice that the dimension is coming from the center of the polygon to the outside. So it's not the full distance. So remember, the W that we're given, the width is 1.75. That's the full width across the flats. So now AutoCAD is asking for half of that. All right. So, and I always get drawings that students turn in that have the hexagon given with the wrong dimension here. So pay attention, people. We're going to use my trick, which is we're going to do apostrophe cal, right? So I type in apostrophe cal. You can see it right there. Hit enter. And I'm going to type in 1.75 divided by 2, right? Because that's half of the width. 1.75 divided by 2. Put that in there, and then there we go. Okay. So if you put in 1.75, you're going to get a hexagon that's twice as big as this one. All right. And then everything will be off. All right. So pay attention to this first part. That's probably one of the more challenging things in this assignment. That's probably the biggest headache for people. So I got the top view done. Now let's do the front view. So I'll just project this down here, and I'll arbitrarily. I'm going to keep it a little bit tight so I can keep my view scale large. So I'm going to click right here, and then I'm going to go down 2.88. Whoops, 2.88. And then we're going to come across, and I'm going to track this down, and we'll go here, and then we'll go here. And I don't know how far to go up, right? Because that surface, the truncated surface, is truncated at 45 degrees. So I'm just going to go up some distance right there. And then I'm going to hit escape to get out of this. All right. Now we got to come from the other end. So I'm going to go back to the line. I'm going to pick this end point here, and I'm going to come down, and notice I have my polar snap at 45 degrees, right? So this is going to help me. If you don't have your polar trap set at 45 degrees, whoops, I think I just turned it off. No, I did. Just make sure that you use 45 degrees here for your angle. So I'm going to go some distance right there, and I can just snap it right to the end right there. And then there we go. And we trim that off. All right. So far so good. Last thing we do for these views is we project this down here for the edge. And we project this down, whoops. And we project this down here for the edge. All right. And we've just completed the two views, the top view and the front view of the hexagon box, the truncated hexagon as it is, okay? These are the views that are given in the book, all right? Now, let me you do not need to do this, okay? You do not need to do this, but I'm just going to do it just to keep these dimensions in mind for you. There's the width, and notice this, the width across the flats. Now, if we were to dimension the width across the corners, that's the width across the corners, right? The corners of the hexagon, right? We don't want that, so I'm just going to delete that. I don't even want you to think about that because that has nothing to do with this. And then the height is dimensioned from the high side, from the long side, and it's 2.88. Okay, so again, these dimensions are just for your reference only. You do not have to put these dimensions in the drawing, all right? But just so you know what we're talking about. All right, so now what our task is now is we're going to unroll this hexagon, right? Remember, this is like a hexagon box, a box that's empty in the middle. So now we're going to unroll it. What we need to do when we unroll it is we need to unroll the sides, and we're going to do it right here in this space right here, right? Because that's the most logical place because we can project it straight across. We need to unroll the sides, and then we also need to take care of the top because there's a top to this and a bottom, right? So we're going to do both of those, all right? So let's start with the unrolling here, okay? So first of all, let's get the... what we're going to do is we're going to unroll, and we have to arbitrarily pick kind of like a starting point. And I'm going to pick, it's actually not arbitrary, but I'm going to pick this back edge right there, which corresponds to this edge as my starting point. Why? Because that's the high side, okay? So watch what I do here. I'm going to copy, I'm going to go to the copy command, and I'm going to copy this, and I'm going to copy it straight over, right? I'm not going to go down or up or anything like that. I'm going to copy it straight across. And again, this is just going to be an arbitrary distance right there. I want to keep it kind of tight because it's going to help with the scaling. Right there. And we'll move it later, so if we need to. So I'm just going to move it right there, okay? Or copy it, I should say. All right, so that's my starting point now, all right? Now, each panel from that, right? Each panel, we have one here. I guess I can't count that. So I'll count here. We have one panel here, 2 panels, 3 panels, 4 panels, 5 panels, 6 panels. Duh, it's a hexagon, so we're going to have 6 panels. So we have 6 panels that are going to make up this box, right? Each panel, what is the length of each panel? Okay, each panel has a length that is this distance right there, right? Or if I measure it right there, each panel is this length right there, all right? Now, we're not going to use that number because, in fact, this number is not accurate because it's just stopping after 3 decimal places. There is, a lot more decimal places down here that have numbers in them. So this is not a complete number. This is continuing on here. But this is basically the length of each panel. So how are we going to get an accurate panel length here? We're going to let AutoCAD do the work. All right. So to do that, we're going to use offset, right? Because basically we want to offset this line for each panel. All right. So watch how we do this. We go up to the offset command. And where it says specify offset distance, I'm going to pick the distance between this point and that point, right? Now, when I did that, AutoCAD didn't just take 1.010. It took 1.010, blah, 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 blah. All those, 13 more decimal places. AutoCAD keeps track of 16 decimal places. Probably more because I'm using a 64-bit version, but nevertheless, it's more accurate than us just typing in 3 decimal places. All right. So then we pick this line and we offset it. And remember, even though that number is showing up as 1.010, that's not exactly what the number is. So we need to go 1, 2, 3, 4, 5. So we have 1 panel, 2, 3, 4, 5, 6 panels. All right, so there we go. All right, so now I'm going to draw a line across the bottom here because that's the bottom of the object. Now the top is a little bit more complicated, right? Each panel is not going to be a full height. In fact, the only full height panel is, well, there is no full height panel. There is no full height panel. Why? Because this panel right here, on that side, I should say, starts at the top, but then it goes down. It has an angled side. In fact, all of the panels have an angled top. All right, so this is where you have to keep track. So again, this is just for your reference purposes only. All right, but I'm going to put a letter right there. I'm going to call this panel A, or edge A. It's an edge. Okay, right there, that panel. Excuse me, that edge. All right, so let me move that a little bit closer there. Okay. Now, I'm also going to, again, just for your reference, I'm going to add additional letters in there so we can keep track of everything. All right, so we'll call this B, and we'll call this C, and we'll call this D, and we'll call this E, and we'll call this F. So we can keep track of each line. Okay, so this is A. Right there is A. Right. So now watch. I'm going to project all these across. And I don't really care where they end because I'm going to trim them later. But I'm going to project these across. These are the heights. The height of each panel, right? Or the height of each edge right here, A, B, C, D, E, F, across here. So as I unfold this, remember, this is A right here. And we're gonna make a standardization here that we're gonna unroll it with the inside facing up. So that means this next one is going to be B. Okay. So let me copy this over just so you can keep track of that. That's B right there. All right. There's B. Where does B end? Well, B ends right there. So I'm going to go from here, the top side, to here. All right. There's B. All right, and I can trim that up right there. All right, I'll kind of trim as I go just to help you visualize what's going on. Then from B, we go to C. So this is C right there. And where does C end? Well, C ends right there. There's C. So this goes from here to here. You see how we're doing it? We're just kind of stepping across using the top view and the front view as a reference to finish this. So we can trim that off. All right. And in fact, I'll just move this down just to make it a little bit more clear. There we go right there. Okay. And then after C, we go to D. Where is D? D is the shortest edge right there. So here we go from C to D, and then we can copy this, and I'll just copy that right there. There we go. And then guess what? We go back up again. From D to E is the same as from C to D, right? So we kind of have already that there. So we go like this, and look how that works out, okay? So I'll copy these over there just so you have a complete reference. Again, please do not show me this on your drawings. This is just for your reference so you can keep track of what's going on. And guess what? This edge, A, is actually duplicated. This edge is the same. All right. And there we go. Now we can get rid of our reference lines here. And guess what? We've just unrolled the sides of this hexagon box. Okay, so now if you print this out and cut out this shape, you will be able to fold these up to make a hollow without a top and a bottom hexagon or truncated hexagon box. All right, of the correct dimensions, 2.88, 1.75. All right, so there we go. All right, now I'll leave these little reference markers on here so that you can keep track of everything. The one thing I will say about this topic, developments and intersections, especially with intersections, is it's very important that you keep track of your edges and projections and your lines in your drawing. That's actually very, very, very important, critically important in the next drawing that we'll do, which is the intersection. Okay, but for this one, it's a little bit more straightforward. Okay, so now since we have the sides done, now we need to draw the top, right? The top shape here and the bottom shape over here, and we're going to do that in the next video. All right, so I'll see you in the next video.